So in this session, we are going to see about automotive steering system, different type of automotive steering systems we are going to see. And before going for the detailed steering system, so first let us see what are all the functions of a steering system. Okay, what are the basic functions of a steering system? Normally, this steering system will enable the driver to regulate the vehicle along the desired path, right? So whether the vehicle want to go in a straight path or in a left direction or in a right direction or along the trajectory, along the required direction which is expected by the rider or a driver. So the function here is the basic function of the steering system is to steer the vehicle or to steer the wheel or to regulate the wheel such a way the vehicle will move along the required path or the intended path or the desired path. Okay, so this is the basic function that everyone knows. And this steering system should also enable the control of vehicle trajectory. It will control the vehicle directions under normal conditions and also in the emergency conditions. Okay, so suppose when the vehicle is running and say it can be the commercial vehicle or the passenger car vehicle. If any objects or any people or any person comes in between, the vehicle should be such a way it should have the emergency condition to stop the vehicle and to have the proper control, and for which the steering system is very much important um, to control the vehicle trajectory in the case of any emergency. Okay. And the last important function of the steering system is that uh, it also helps for the proper handling of the vehicle. Okay, so we are discussing the ride and handling properties. So it's very important that the handling of the vehicle is being controlled or taken care by the steering system. So there is a term called fifth wheel steering. We will see what is that fifth wheel steering. Okay. Um, so assume that this is the front wheel. Okay. I'm turning the wheel in this direction. Okay. So during the cornering or during the right turn. Okay. So I'm turning the wheel like this. Assume that it has two wheel in the front wheel. Okay. Uh, so I'm turning the direction in right direction. Okay. This is the corner. Okay. I am turning the vehicle like this. When the vehicle is turning, what happens? The front wheel will be like this, okay? And rear wheel remain same. Okay, now what I'm going to do is listen this carefully. I'm going to draw a line from the front wheel. I'm going to draw a line like this, which is shown in the dotted red. Similarly, the rear wheel, I'm going to draw a line like this. And both this line and this line will meet at this point called a center point, which is nothing but the center of turn. Okay, and the point which is connecting this center of turn to the center of gravity of the vehicle, CG, you call this as CG, right? Center of gravity between uh, the front wheel and the rear wheel. The point which connects is nothing but the center of gravity, and the line which is connecting the center of gravity to the center of turn is nothing but the turning radius. Okay, it is in short, it can be called as TR or turning radius. Okay, so I repeat again. When we move the vehicle in the right direction, okay, so this is nothing but a wheel. Okay, the front wheel will be turning in this direction. Okay, and the line extending the front wheel is the red line, which is shown here, and the line which is extending the rear wheel is shown here, and both these two lines will meet at a point called center of turn. Okay, and we have a center of gravity which is between the front wheel and the rear wheel, and the line which is connecting the center of gravity to the center of turn is nothing but turning radius. Okay, now let us see the fifth wheel steering. Okay, so for example, you see here when the entire vehicle is turned in the right or left. Okay, so when you turn the vehicle in the left, what will happen? This center of turn and then the center of radius will shift towards the left direction. Okay, now it is in the right direction. No, so it will get shifted to the left direction. Okay, now here when when the vehicle is steering in the right direction, say here, what happens? The entire axle or the front axle is turned about its point. You know, this is the axle which is between the two wheels. Okay, only the front axle gets turned about its point. Okay, the rear axle is remain same. Okay, so here when you turn the vehicle in the left or right, what happens? The front axle is turned about its pivot axis. This is a pivot axis. Okay, and because of this, what happens? Uh, because of this front axle which is changing the turning, which is turning, this also changes the orientation of the front wheel. Okay, from its side ahead position. Okay, so it is not now straight, right? It is turned. Why this front wheel is getting turned? Because the front axle is turned about its pivot axis. Okay, now you need to have a high force to rotate the entire axle, right? Because we have the front axle and rear axle, and also it is also having its own weight. Okay, so the point here is, or the challenges lies here is how much force is required to rotate the entire axis. Because if you don't have the force, what normally will happen is that you cannot move the, or you cannot rotate the axis, or rotate the axle basically, right? So you need to have the high amount of force to rotate the entire axle, which is again rendered, and it is unsuitable as the speed increases. So there are two challenging criteria here. Okay. So what will happen when the speed is in low and when the speed is in the high speed? Okay. When the speed is low, it is easy for the rider or a driver to rotate the axle because less force is required compared to that one when the vehicle is in the high speed and or in the medium speed, because normally during the cornering what happens, you don't turn the vehicle in high speed, right? uh, Especially when you're cornering the vehicle left or right, you normally need to have some force, okay, to rotate the entire axle. But even though when I say small force, still you need to have a reasonable amount of force which is considered as high. And when the speed is still further increasing, and if you want to rotate the axle, front axle, it becomes sometimes difficult and it will lose its stability, right? will lose its stability, which will result in some mishap. Okay. Now we have an important term called Ackermann steering mechanism. Why this comes is the name of the inventor is Ackermann, so that's why the name comes Ackermann steering mechanism. So the point here is, or the main idea here is, when you're taking a turn, okay, let us take this as a vehicle having the front wheel and the rear wheel. Now you see the vehicle is turning it towards the right. Oh, this is the inner wheel, this is the outer wheel, right? And front wheel is getting steered. And this front wheel is getting steered because the front axle, that's what we have seen, right? The front axle is turned about its axis. The front axle is turned about its pivot axis, which is leading to steer the front wheel. Now, I told you in the last slide here, you can see when the vehicle is turned right, you can see the center of turn is meeting at a point in the right direction. Similarly, when the vehicle is turning towards left, the center of turn will meet at the left direction. This center of turn is nothing but instantaneous center of turn. I am going to put this center of turn as the point O, okay? And we have a two wheel, one is inner wheel and this is the outer wheel, okay? Now what I'm going to do is, I'm going to connect the point O, instantaneous center O, to the inner wheel center, okay? The inner wheel center, which is perpendicular. You can see this is perpendicular, okay? Perpendicular to the longitudinal axis of the wheel, okay? Similarly, I'm going to connect the point to O, which is perpendicular to the longitudinal axis of the wheel. So you have the wheel which is having the vertical axis, which is like this, and this is the longitudinal axis, and you also have the lateral axis as well. And lateral means this one will move laterally. And now you see here, I also told you the CG lies between the, the front wheel and the front axle and the rear axle. Center point between the front axle and rear axle is the center of gravity CG. And the line which is connecting the CG to the instantaneous center of gravity, instantaneous center of turn, is nothing but the turning radius called R. Okay. Now, while taking a turn, the axis of rotation of the front wheel should intersect the axis of the rear wheel at a common point. This is the common point, okay? And I told you this common point is nothing but instantaneous center of turn, okay? So I'm mentioning this as O. And while taking a turn, the inner wheel has to travel on a. You see, this is very important, very interesting. You see here, while taking it a turn, now here it is left turn. Okay, while taking the turn, what happens here? The inner wheel has to travel on a circle of smaller radius than the outer wheel. So assume that this is the O, and when you're taking the arc, taking the geometry arc, what I'm going to take, I'm going to keep the point O, and from O, I'm going to draw a circle or arc. Okay, this is the inner wheel arc, and this is the outer wheel arc. Okay, so what will happen? the inner wheel has to travel a circle. When you draw a arc, what happened? The circle will be created, right? And while taking a turn, the inner wheel has to travel a circle of smaller radius. The radius is smaller, right? When comparing to that of the outer wheel, the outer wheel has to travel on a higher radius than the inner wheel. Okay, hope this point is clear. Okay. Hence, the steering system should enable the rotation of the inner wheel by a larger angle, okay, than the outer wheel. You see here, I told you to draw a line, it should be the center connecting the center point of the longitudinal axis of the inner wheel to that of the instantaneous center of turn O. Assume that point, let assuming taking the triangle O, you can also you can take a point O, and this is the vertical axis. X-axis, you can take X-axis, okay, and O, this is so kind of normally the Y-axis should be straight, but it is basically having a angle. You see here, this angle between the inner wheel to that of the instantaneous center of turn is higher than the angle between O to that of the outer wheel, okay, with respect to instantaneous center of turn. Okay, you see here this angle, when you take this angle, right, the angle is higher. The angle is higher when compared to, so the angle is lesser. The angle is lesser in the case of outer wheel when compared to the of inner wheel. Okay, that's what is mentioned here. The steering system should enable the rotation of the inner wheel by a larger angle than the outer wheel. Okay, so this is the basic of Ackermann steering mechanism. Now we are going to see in a detailed way from this basis. Okay. Now we are going to have some linkages to form a geometry of the steering. Okay. The steering geometry we are going to define for this mechanism, Ackermann steering mechanism, using the steering geometry. And here what we are going to do is we are going to have different linkages. Okay. And these linkages we are going to combine, and why these linkages needs to be combined is that uh, the linkages helps to provide the inner and outer wheel to trace out the circles of the different radii. Okay, so I told you you have a different radius. Okay, the inner wheel have to travel a lesser radius than the outer wheel, and as a result of that, the rotation of the inner wheel will be with larger angle. The angle traveled by the inner wheel will be much higher than the angle traveled by the outer wheel. Okay, and this mechanism is normally going to happen with the help of linkages. We have a different linkages. You see here, this is the linkage. Okay, you have linkages, one linkages, and it is a blue color, right? You have linkages. The different parts we are going to see. You have the tie rod, you have the axle, you have the kingpin, you have the bearing. Okay, we are going to see all these things, and each and every uh, two parts are connected by linkages. You see here, this is one linkages, this is one linkages, this is one linkages, and this is one linkage. Okay, you can see the linkages, and this forms a steering geometry. which is nothing but the combination of linkages that provide for the inner and outer wheel to trace out the circles of different radius. Okay. Now we'll see what are the different linkages. I told this is the front axle, right? This is one linkage. And you see here that this is the track rod, or called this as a rack. Okay. You have a point which is nothing but the kingpin or a ball joint. In the case of commercial vehicle, you call as a kingpin. In the case of a car, you call this as a ball joint. Okay. And the point which is connecting the track rod. Okay, this is the track rod. It is nothing but the steering pivot point. Okay, steering pivot point. And you see here, when the geometry should be such a way, the rear axle and the steering pivot point should steering pivot point and the rear axle center point, steering pivot point, and the ball joint or the kingpin point should form a straight line like this. And this is in the inner wheel. Similarly, on the outer wheel also, it should form the line like this. Okay. And you have the point which is connecting the steering pivot point and the kingpin is nothing but the tie rod, and it is put together. It is called as tie rod plus steering arm assembly. It is called left tie rod and left steering arm assembly, and this is called as left steering point, and this is the left kingpin or left ball joint. As I said, the kingpin is used in the case of a commercial vehicle, and in the case of a normal passenger car, you call this as a ball joint, right? And similarly, when you have the right tie rod or the steering arm and the steering arm assembly, and you have the right kingpin and then the right ball joint, and you have right pivot steering pivot point at this location. Okay, and we need to form a triangle like this when the vehicle is, it's not still here, the vehicle is not still, right? The vehicle is in the straight position. Okay, that's why you can see the wheel is straight and it is not turned. Okay, and so as I said, you have the different linkages: front axle, track rod, tie rod plus steering arm assembly. Okay, and kingpin. All these forms linkages. So that's why I mentioned that this steering geometry is defined with the help of the combination of linkages, which is been provided from the inner end and then the outer end to trace the different circuit radius. Now, let us see the key points here. The two ends of the steer axle they have a spindle which is pivoted around a kingpin. Okay, you have a spindle which is pivoted around a kingpin or a ball joint. This is the two end of the steer axle, right? One end is this and another one is this. And these two ends of the steer axle, they have a spindle which is pivoted around a kingpin. And you can see the tie rod are attached to this kingpin. And you also have the steering point, pivot point, is placed on the line segment. This steering pivot point is placed on the line segment joining the corresponding kingpin to that of the center of the rear axle, right? That's what I told you. Uh, Left kingpin, left steering pivot point, and the center, rear axle center will meet at one point, which will connect the rear of the center of the rear axle center point to that of the center of the right pivot point to that of the center of the right kingpin. Okay. So this is the geometry, Ackermann steering geometry. Let us slightly go in a detailed way. Assume that this is the wheel A, B, C, D, and the vehicle is turning in the right direction, sorry, left direction. This is the continuation of the last slide. And the distance between the center of turn, instantaneous center of turn O, to that of the center of the wheel. Okay, wheel width. You call this as the wheel width, right? The center of the wheel width. You call this as. We are going to define this with the radius. Means with the term called R1. You can say this is the R1. Okay, and we have seen that R is nothing but the turning radius in the previous slide, and you have an angle. I told you the different angle. Okay, and you also have the track W, which is the center of the wheel, A to B and C to D. You can see this, the W is nothing but track. Okay, and you have the length, overall length of the wheelbase length is L. Okay, and you have CG, the distance between the front wheel. Is the front wheel, right? Front wheel to the of the CG is the length L1, and the distance between the rear wheel to the of the CG is nothing but L2. You see here, L1 is not equal to L2. Okay, because normally you should not think that this CG lies between. Uh, it's not lying. It's lying between the front and the rear wheel, but it is not lying to the center of the of this line, right? But sometimes you may feel that the CG should be here. It is not that way. The CG lies between the front to the top of the rear, and normally the length L1 is lesser than the of L2. Okay. Now we are going to consider a triangle OA. This is okay. I'm going to write triangle OAC, and I'm going to try one more triangle called O, B, and D. Okay. So when I'm taking OAC, it is I'm taking the left wheel of the front and then left wheel of the rear. When I take O, B, and D, I'm taking the right wheel of the front and the right wheel of the rear. Okay, first I'm going to take OAC. Okay, and you also have angle. I have told you, right? The angle. This is the angle I told. The angle which is connecting the O, the front wheel left side to that of the center, instantaneous center of turn. You call as the angle. So similarly, here we are going to define with some terminologies. So inner wheel, this is the inner wheel, this is the outer wheel. So inner wheel is noted as I and outer wheel is O. And you have the inner wheel steering angle. So this is the del I, which is nothing but the inner wheel steering angle. Okay, that is the angle which is between the center of turn, instantaneous center of turn to that of the inner wheel. You call this as the inner wheel steering angle. Similarly, the angle between the instantaneous center of turn to that of the outer wheel steering angle is nothing but del O. Okay. Now we are going to write a governing equation or the angle equation. You see here theta is nothing but angle. So first we are going for del I, which is nothing but inner wheel steering angle. So what is nothing but tan theta? So when you take OAC, when you take the angle theta, tan theta is nothing but AC by OC. Similarly, so here that theta is nothing but what? Del I, right? Similarly, when you take for the triangle OBD, what is the tan theta? Theta is nothing but del O, right? And when you take OBD, what happens? Tan theta is nothing but BD by OD. Okay, that is written as BD by OD in the case of triangle OBD, and in the case of triangle OAC, it is written as tan del I is nothing but AC by OC. Now let us see what is AC. AC is nothing but what? AC is nothing but L, right? And OC is nothing but what? OC is nothing but OC, right? It is nothing but R1, and it is lying between this and this, right? So R1 minus W by 2, that will give you the OC, right? So that's what is written as AC by OC is nothing but L by R1 minus W by 2. Now, you know that cot theta is nothing but the inverse of tan theta. Okay. So inverse of tan theta, how I can write as cot theta, which is nothing but cot theta is equal to the inverse of this R1 minus W by 2 by L. Okay. So let us consider this as equation number 1 for the triangle OAC. Similarly, for a triangle OBD, we take cot theta, which is reverse of the tan theta in this triangle. Now, what is BD? BD is nothing but a wheelbase L, right? And let us take OD. What is OD? OD is nothing but R1 plus, you see, W by 2. This is W by 2 is like this. And when you take cot theta, which is nothing but the inverse of the tan theta, how it will be? It will be R1 plus W by 2 by L. Now, the condition of the Ackermann steering is that the equation, when you subtract the equation but true with respect to 1, 2 minus 1 is nothing but what? Cot theta minus cot theta, cot del O minus cot del I is nothing but W by L. Okay, so you should design the steering mechanism or steering system such a way the angle of del O and the angle of del I and the W is nothing but a wheel track, and the length is nothing but a wheelbase. So the ratio between the wheel track to that of the wheelbase should be equal to the cot of inner wheel angle minus cot of cot theta of outer wheel steering. Okay, this is the Ackermann steering mechanism or a condition that it satisfy. Okay, now moving ahead, So it's not only a condition, but also it is providing a constraint, right? Because you cannot change a wheelbase, right? You cannot change the wheel track. It is fixed already. Okay. For the fixed W and fixed L, okay, there's a constraint that we are going to experience with respect to del O and del I. Okay. And when we are subtracting, we are getting W by L, the equation number 2 and 1. We are subtracting. And what will happen when we add 2 and 1? What will happen? Okay. Cot del I plus cot del O will be equal to, you can see here, R1 minus W by 2 by L plus R1 plus W by 2 by L. How we can write? Okay, it becomes 2R1 by L, right? Because R1 plus R2 is 2R1 by L, and this W by 2, this W2 will get cancelled. So it is nothing but 2R1 by L. Okay. And we know that R1, how we can write R1? You see here, R1 is nothing but what? L of cot del I plus del cot del O divided by 2. Okay. Now we are going to apply a theorem called Pythagoras theorem. Okay. We are going to apply a term called Pythagoras theorem. So this is the turning radius R. Okay. And this turning radius R is equal to the square root of, okay, it is nothing but the square root of L2 square plus R1 square. Okay, so when you take triangle OCG, O to CG point, and the track with the center, we will track center. Okay, you can see here, it is when you take the turning radius R is equal to the square root of, when you apply the Pythagoras theorem, the square root of one side to the top, the other side. One side is L2, another side is R1. So when you take the square root of L2 square plus R1 square, which is nothing but the turning radius R. Now how I can write? R is nothing but L2 square plus, we know R1, right? This is the R1. So I am applying the square root for this R1. It becomes L square cot del I plus cot del O by the whole square by 2. The whole square is nothing but 4. Okay, so this is the turning radius. Okay, of the Ackermann steering condition of this mechanism. Now moving ahead, what happens? This is going to form a trapezoidal shape. You can see this is the trapezoidal shape. And I told this is the track rod, and this is the kingpin, and this is the tie rod plus steering arm. Okay, this is also the tie rod. Okay, and now so this is what we have made as a turning radius R. And how one can realize the condition? Okay, the question point right here is, while we are designing the steering system, how one can realize this mechanism? Okay, what are the governing parameters? Okay, let us see the governing parameters. So you have parameter D and beta. D is nothing but the the this nothing but offset arm length. Okay, which is nothing but the tie rod and steering arm. Okay, and the offset D is nothing but the offset arm length. This is the arm length, right? And you have a beta, which is nothing but the angle between the tie rod to that of the center of to that of the axis. Okay, this is the longitudinal axis. Okay, to the longitudinal axis of the inner wheel. And similarly, you also have the angle between the tie rod in the right side to that of the axis of the right wheel of the front. Okay, and what we are going to do here is we are going to form a trapezoid like this, and we are going to see what are all the governing conditions that it should satisfy such a way how we are going to design the steering system which will satisfy all this requirement, satisfy the requirement of the steering system. Okay, so it should satisfy this equation, it should also satisfy this equation. At the same time, it should also ensure that during the turn, it's the inner wheel angle, outer wheel angle, steering angle, all this should meet the requirement. Okay, so now what we are going to do is we are considering this is xy, yz we are taking xy z, this is z. Okay, this is z, xy z, and xy z is nothing but what, xy square plus yz square is equal to xz square. This is as per the Pythagoras theorem. Okay, so xz is nothing but what, square root of, we know that xz, right? Xz is nothing but what is x and z? It is nothing but w, track with w minus this is w minus this distance. Okay, and this distance is nothing but 2d sine beta. This is one. This is one d into sine beta. Okay, because when you apply when you apply the distance between this is in combining the offset angle, offset arm length and the beta. Okay, so how we can write it's d sine beta, and when you write, because you see w is nothing but what, wheel track, right? Wheel track is, this is the wheel track, and why you have 2d sine beta, because this is one direction is d sine beta. Okay, but also you have additional length here, right? Because xz up to here. So here one side is d sine beta and another side is also d sine beta. So when you add this sine beta, d sine beta plus this sine beta, it becomes 2d sine beta. That's what is mentioned here. Similarly, you have xy. Okay, let us see xy letter. We will see yz. It becomes easy for you. Yz. What is yz? Yz is nothing but w. Okay, plus when you add when you use the logic here, what it becomes? It becomes d sine del o minus beta. Okay, you have the del o minus beta here, minus when you apply here it becomes del o minus beta, and here it becomes because we're going to minus this side, right? Minus d sine del I plus beta. So here you are going to add and here you are going to minus, so that you get yz, and xy is nothing but xy is nothing but applying the cos theta. You get d cos del O minus beta minus d cos del I plus beta. Now you apply the Pythagoras theorem. Xy square, this is xy, okay, the whole square is plus yz whole square, so yz is this. When you apply all these things, it will be equal to w minus 2d sine beta the whole square. So again, this condition you should meet. Okay, that's why how you one can realize the condition of this Ackermann mechanism is that while designing the steering system, you should ensure that the angle, I mean the parameters d beta, okay, the d beta should be such a way this condition should be satisfied. Okay, not only see if I'm putting you the questions, what is the governing equation or governing parameters which is correlating d parameters d beta angle del I angle del O, okay, so then this is the governing equation, okay, and I can also correlate this with W by L or W and L. The equation which is governing the del O and del I is also to be taken to consider along with these parameters d and beta. So when you design the steering system, what are the parameters you need to consider? Parameters d, beta, del I, del O, wheelbase, and also the wheel track. Wheelbase, wheel track. You have to consider del I, del O. Okay. What are the other things? And in addition to these parameters, you should also consider the offset arm length d and the angle beta. Okay. Now, this is the steering mechanism, Ackermann steering mechanism. Let us go to the different types of steering system. You have a manual steering system and also the power assist steering system. And when you take the manual steering system, you have two type of system. One is rack and pinion system, and the one is a worm gear system. When you go for a power assist steering system, you have a hydraulic system, you have the electro hydraulic steering system and electric hydraulic system. System. Now, before going there, what we'll do is we'll see the different types or different components of the steering system. Okay, this is the steering wheel, and this is the collapsible section column. Okay, and you have the flexible coupling, you have the universal joint, and you have the intermediate shaft, high shaft, and this forms the steering column, and you have the steering gear, and you have the pinion steering or the gearbox. Okay, these are typical components of the steering system, which involves first is the steering wheel, and next is the steering column, which consists of the intermediate shaft and the universal joint. And you have the steering gear, which provides the mechanical advantage, which is nothing but the force which is required, the input to that of the output, and this steering wheel or the steering column should be collapsible one, because in the case of any accident, what happens when going for a front collision, vehicle collision, this steering column should be collapsible. It should not the driver will be sitting here, right? This steering wheel should not come near to the chest of the driver, and it should not hit. So that's why during the accident or any undesirable event, uh, the steering wheel should collapse. It should come down and it should not come up. Okay, if it is coming out up, what happens? It will hit the chest and it will damage. It will create a problem to the driver. So that's why this system should be a collapsible one, so that it will collapse and it will move down and it will not move up. And this steering mechanism forms different linkages. I told, right? Track rod, rack, tie rod, pitman arm. Okay, we are going to see what is the pitman arm. So we call this as a pitman arm, and it is going to have the steering arm, steering knuckle, ball joint, and also the kingpin. So in the case of commercial vehicle, we call this as a kingpin, and in the case of car, we are calling this as a ball joint. Okay, let us see the different aspects now. What is the steering ratio? Steering ratio is nothing but the ratio of the angle through which the steering wheel is turned to the corresponding angular displacement of the steering wheel. Okay. For most of the passenger car, the steering ratio is between 12:1 to that of 20:1. Okay. And this gear reduction is required. Why you need to have the gear reduction? Is the steering gear, right? Here the gear reduction is going to happen. And why this gear reduction is required? Because it is necessary, it is important to achieve the necessary advantage, mechanical advantage. Since we need to turn the loaded tire, the tire is getting loaded, right? Because when you see the vehicle, the front wheel or the right wheel, the complete load is going to act on the wheel or the tire. Okay, so the gear reduction is very much important to achieve the required mechanical advantage. Since we are going to turn the loaded tire, so how we can define the mechanical load advantage? That is very important. Okay, it is nothing but the measure of how much force you are applying to so that the mechanism can be amplified. Okay, it's nothing but the ratio of the output force to that of the input force. Okay, and the ratio of the load to that of how much load you are applying, and to that of the effort that is being applied. See, once you apply the load, the effort also goes to happen, right? And once again, I'm going to define the steering ratio. Okay, steering ratio is nothing but the ratio of the angle through which the steering wheel is turned. Okay, the steering wheel is turned either left side or right side, and the ratio of the angle through which the steering wheel is turned to that of the corresponding angular displacement of the steering wheel. Okay, um, the original angle to that of the corresponding angular displacement of the steering wheel, that we call it as a steering ratio. So when you're having the steering wheel, let us consider the steering ratio of 12. Okay. When you say 12:1, you are considering a steering ratio of 12. It is required that the steering will be rotated by 40° from the center to that of lock on either side. Okay, let us assume let us assume that angle is 40. Okay, and the steering ratio is 12. So what is steering wheel? Steering wheel angle is nothing but 12 into 40. Assuming that if it is 20, the steering ratio is 20, then 20 into 40 will be the steering wheel angle. Now we are considering 12. 12 into 40 is 480. How much turn is required for the steering wheel? One complete turn of the steering wheel, one rotation is nothing but 360 degree. And when you have a steering wheel angle of 480 degree, it is nothing but one is 360, and you have one by third of the steering wheel, which is nothing but from center to the lock. Okay, this is that center wheel, means steering wheel is in the center. You have left lock and also the right lock, beyond which we cannot further steer, right? That is a maximum thing. Okay, so you call from center to the right lock and also center to the left lock. You call one as left steering wheel angle and right steering wheel angle. But when you consider the complete 360 degree, so lock to lock turn, which means this lock to lock turn is 360 degree you call. Okay. So for this is 480 degrees for one turn. Okay, one turn is 1/3. When you take this lock to lock, what will be? It will be 2 times. So it will be 2 into 2/3. Okay. So now let us see a different type of steering system. Okay. The first one is the manual assist steering system. That's what I mentioned, that the important thing here is to go with the Bitman arm steering system. You have just a second. Okay, so the first type is going to be the Pitman arm type steering system, and this is the steering wheel, and this is the steering column. You have the steering gearbox, and this is the track rod. Okay, and you have the arm or the linkage which is connecting the track rod to that of the steering gearbox, and this is nothing but a pit arm. Okay, so you know the rotating motion of the steering wheel is converted to the linear motion with the help of the arm called pitman arm. Okay, and you have two arm. One is left. You also have the left. You have left idler arm, the left side, and you also have the right idler arm as well. But again here the right idler arm is nothing but the pitman arm. Okay, and this is also a pitman arm, but this is going to be ideal because the steering is going to happen only because you don't have the two steering wheel, right? Only one steering wheel. And this is the thyroid, and this is the stub axle, and tire. Okay, stub axle of the wheel, and going to the tire. See, when you apply the rotary motion of the steering wheel, what happens? This pitman, the motion is getting transferred to the steering box. This rotary motion is converted to the linear motion with the help of the pitman arm, and then the load gets transferred from the axle to that of the tire. Okay, and the load is finally going to the tire. That is a basic fact that everyone knows. Now let us see the key points of this pitman arm type. This is going to be the warm gear based type. Okay, and this pitman arm is equipped with a steering box. This is equipped with a steering box which is having a high steering ratio. Okay, the steering ratio is nothing but the ratio of the angle through which the steering wheel is turned to that of the corresponding angular displacement of the steering wheel. And as a result of this, what happens? when you have the high steering ratio, we have also seen that high steering ratio is required for the high mechanical advantage, for the better mechanical advantage. Okay, when you have high mechanical advantage, what happens? The load to effort will be much more higher. Okay, which means the ratio of the output force to that of input force will be higher, which means with less input force, you can get the better output. Okay, so that's why it gives a better mechanical advantage, and even you can have less feedback less feedback is available to the driver under changes in the road conditions. Okay, so these are all the advantages. So these are the advantages, but there is one more disadvantage you have with the help of the manual assist steering system. So the feedback is the less feedback is available to the driver when there is a change in the road condition, because the road is not going to be even always, right? You have a rough road, hilly area, bumpy road condition. Okay, so under the different road condition, the feedback is getting changed, and this is one disadvantage that we have. And you have various other systems, other types. We have worm and sector steering box. This is the worm and sector steering box, and we also have worm and roller steering box. In the case of worm and sector steering box, it looks like this. You have this is the steering column. It is connected to the steering wheel, and you have the worm gear. Okay, and this is connected to the sector gear. Okay, and this is the pitman arm. Okay, you see here the motion is transmitted from, means when you rotate the steering wheel, uh, the movement is going to happen to the steering wheel shaft, and that motion is transmitted from, and again it's going to the worm gear, and the motion is transmitted from the worm gear to the sector gear. Okay, and it is mounted on the same shaft as that of the pitman arm. So which means worm gear, sector gear, and pitman arm are mounted on the same steering column shaft. Okay, this is one type. And second type here is you have a same mechanism where steering wheel to that of steering column to that of the worm gear, and you also have a sector gear in the case of worm and sector steering box. But here the sector gear is replaced with a roller steering box or a captive roller. Okay, and when the worm gear turns, what happens when the worm gear is turning? The roller will twist the cross shaft. This will twist the cross shaft, and it will rotate the pitman arm. Okay, uh, so which means same mechanism, similar to that of the last one. It will rotate the pitman arm, and once that pitman arm, what will do is that it will convert the rotation movement into the linear motion, and the load goes to the wheel and tire. You have yeah, one more type of this mechanism is called recirculating ball steering box. So same steering wheel, steering shaft, and this is the worm gear. And here what happens? You have a ball nut which is messed with the worm gear. Okay, you can see the balls, and you have how the movement is going to happen. Let us see. The rotation of the steering wheel is going to the motion of the ball nut. This is the ball nut, and then you also have the sector gear, and finally this will rotate the pitman arm. Okay, here why you need to have the balls? Okay, why you need to have the ball in the worm gear? The function of these balls is to reduce the friction and also to reduce the wear. And this is the common type of steering box which is used in a pitman arm. You have various types, right? So you have the pitman arm type steering system. You have the worm and sector steering box. You have worm and roller steering box, and then pitman arm recirculating body steering box. Out of which this has been most commonly used steering box is used in the pitman arm type because of the presence of the balls, which is helping to reduce the friction and also the wear. Okay. And here the ball net is meshed with the worm gear. And here the rotation of the wheel, steering wheel to that of the motion of the ball net, and then the sector wheel, and finally the rotation of the pitman arm. Okay. So these are all the types of pitman arm type steering system, which is the first type. Let us go to the other different types of the steering system. You have a rack and pinion steering system. In this system, you have a steering wheel, you have a flexible collapsing steering column, you have a universal joint. So here you have a pinion and rack and pinion. Okay. So this is mostly used in commonly used in most of the cars. And here the rotation of the steering wheel to that of the rotation of the pinion, and then the linear movement which is going to happen to the rack. And this is more compact and it is having less components and it provides a more direct path to the steered wheel. So this is one of the advantage of this rack and pinion steering system. There is a factor called the C factor. So the commonly used steering system is the rack and pinion steering system. So we have the factor called C factor. What is that C factor is all about? It is the distance which is traveled by the rack in mm. You see here, this is the rack, right? It is nothing but the distance which is traveled by the rack in mm. When the steering wheel is turned by one revolution, one revolution of the steering wheel is nothing but 360 degree. And the rack speed the rack speed is when you're neglecting the sleep, this rack speed is nothing but VR is nothing but the velocity or the rack speed, okay, which is nothing but omega s by 2 pi into c by 1000, okay, which can also be written as omega s into c by 2000 pi, where omega s is nothing but the angular speed, or it is also called as radian per second of the pinion. Okay, how the correlation is going to happen? Okay, you see here, this is the rack and pinion steering system, which is mostly used in cars. You see the rotation of the steering wheel is this the rotation of the steering wheel, then the rotation of the pinion is going to happen, and then the linear motion of the rack is going to happen. Okay, and how we are going to consider the C factor? C factor is nothing but the distance which is traveled by the rack in mm when the steering wheel is turned by one revolution, which is 360 degree. And this rack speed, which is going to travel in linear motion in mm, is nothing but the ratio of the angular speed of the pinion to that of means the product of angular speed of the pinion to that of the C factor. And this C factor is nothing but the distance traveled by the rack when the steering wheel is traveled by one revolution. Okay. And we also have a torque called TS, which is nothing but a torque on the pinion required to obtain a rack force of F4. Okay. Now this how overall efficiency we can go. Let us see. Efficiency of the rack and pinion. Okay, the overall efficiency of rack and pinion is again or you can see here TS into WS. TS nothing but the torque on the pinion which is required to obtain a rack force F4 into velocity VR. Okay, VR is nothing but the velocity or the force. Okay, and omega is nothing but the angular speed. And this TS, then how we can write TS is nothing but F4 into VR divided by this overall efficiency of RP, which is nothing but the rack and pinion into WS. So how we can write? We know that VR is nothing but WS into C, WS into C by 2000 pi, and this WS and this WS will be cancelled. So it will be F4 into C by 2000 pi divided by efficiency RP. Okay. And this rack and pinion steering system is very compact and this has less components. And this provides a direct path to the steering wheel. Here, the rotary motion of the pinion is converted to the linear motion of the rack. Okay, with this mechanism. Now we have the important types in which the power steering comes into picture. Because what happens when you're increasing the vehicle mass and then the speed and then faster steering response, all these are very much important. You need to have a more robust steering torque at the steering wheels. Hence, we are going for the power steering type. And this can be achieved by increasing the steering ratio. So we have to see, you've seen the steering ratio, right? Uh, so by increasing the steering ratio, we are going for a faster response to have the more steering torque at the steering wheel. And this can be achieved by increasing the steering ratio. However, this would also increase the number of steering wheel turns from lock to lock. We have seen center to lock, left lock, and also the right lock. By increasing the steering ratio, we are increasing the wheel turns from lock to lock, and this has motivated for the development of the power assisted steering. And again, this power assisted steering system mechanism is going to have three types. One is hydraulic power steering called HPS, electro-hydraulic power steering EHPS, and electric power steering EPS. Okay, first is the speed-dependent power-assisted steering system. At low speed, the amount of steering assistance is higher to account for the tight parking or slow speed or the cornering maneuvers. And the amount of assist is reduced as speed is increased to avoid too much steering. Okay. Basically, the steering effort you can reduce when you're going for a power assisted steering system. That is the key point here. And first one is the speed dependent power assist system. And here we go with the first system called hydraulic power steering system in this power steering system. So what happens here? It uses a hydraulic fluid pressure to assist the steering. You have the hydraulic fluid pressure to assist steering. And you have the different components like reservoir, pumps, hoses. You see here, this is the system where you have the hydraulic components. It is having the pump, it is going to have the reservoir, the hoses, control valve, pressure relief valve, hydraulic cylinder, the power cylinder. Okay. And this control valve is typically mounted we also have the control valve, right? Steering control valve, which is typically mounted at the end of the steering column. Okay. In the previous cases, we have seen you have the pinion and you have the worm which has been fitted at the end of the steering column. But in this case, you have the control valve, which is typically mounted at the end of the steering column. It directs the fluid flow to the appropriate side of the power cylinder piston. And the piston in the power cylinder is directly acts on the rack. Okay. And the motion goes to happen. Here we are going for hydraulic assistance. And you see here, this is very interesting. And you are going to have a vent type pump. Okay. And the vents, you see, this is the hydraulic oil coming from the reservoir, and it goes to the vents, which is you have different slots in the vents. Okay, again, it goes to the hydraulic outlet to the steering control valve. Okay, it is having the rotor. And this is the steering control valve. This is how this is the you have the steering control valve. This is the steering control valve. This is the exporter view of the steering control valve where it has a lot of spines, which is connected with the steering wheel. And when this vent type pump is in center position, the pressure is in the right chamber and the left chamber of the power cylinder is going to be same. The pressure in the left and the right of the power cylinder is going to be same. We have two, left and right. Okay, so the pressure is going to be same when the steering wheel is in the center position. Okay, and you can see the movement of the hydraulics. Okay, how it is connected with tank and ports connected with left chamber, port connected with the right chamber, ports connected with the hydraulic pump. Now, what will happen when the steering wheel is moving towards the right? Okay, when you're moving the steering wheel towards right, what happens? The net assist force in the power cylinder to support it. It will support a right turn with the help of a power cylinder where the force is getting assisted. When you move the wheel towards the right direction, you can see here the movement, how it happens. The pressure from the pressurized oil from pump goes in this direction to the pressurized oil to the right chamber. And this is the return, I mean, so this is the return oil from the left chamber goes to the hydraulic oil, returns to the tank. And this is the pressure oil coming from the pump and it goes to the pressure oil to the right chamber. And this is the return oil from the left chamber which is going to the hydraulic oil, returns to the tank. Again, the hydraulic oil returns to the tank. Okay, this is how the movement are going to happen in the case of the steering wheel when it is moving to the right. What happens when the steering wheel is moving to the left? Is the pressurized oil from the pump. It goes to the pressurized oil to the left chamber. In this case, it's right chamber. It is the pressurized oil goes to the left chamber because of left movement. Similarly, the hydraulic oil returns to the tank from the right chamber. It goes to the returns to the hydraulic oil to the tank, and hydraulic oil returns to the tank. In the case of previous cases, the oil return oil from the left chamber moves to the hydraulic tank, but here the oil from the right chamber moves to the hydraulic tank, returns back. Similarly, what happens? The return oil from the right chamber is moving to the hydraulic oil tank. Okay, returns to the tank, and also the pressurized oil from the pump goes to the left chamber. Okay. And there is some limitation in this case. Okay, what is the limitation of this hydraulic steering system? the limitation here is the pump continuously moving, and there is going to be energy loss. Okay. It does not work if the engine is stalled. So these two limitations you have in this case. You also have different types of steering system. Again, the next steering system again is electro-hydraulic power steering system. It consists of a motor unit, pump unit, MPU, with the pump being driven by the electric motor, and it saves energy. Whereas in the case of previous, energy loss is going to happen. Here, it saves energy since the hydraulic pump can be operated whenever it is required. And we also have an electronic control unit which is used to control the motor. And these are all the different points with respect to the electric power steering system. This electric power steering system, it consists of a electric motor which directly provides the steering assisted system. On-demand assist system you have, which will assist whenever it's required, and whenever the driver steers the vehicle, it is very much useful for assistance and handling purpose. And this EPS also lower the fuel consumption and reduce the CO2 emissions. And this, in the important feature of this EPS is the power assist characteristics can be readily changed or readily controlled by appropriately programming the motor's ECU. It can even work when the engine is stalled, whereas the previous case, when the engine is stalled, it cannot work. But this electric power steering can work in that application. And the energy density for the motor power source should be high enough to enable the application in heavy vehicle. This application can be used in heavy duty vehicle or commercial vehicle where the load application is also on the higher side. Okay, let us see the interesting factor here. See, we have seen the kinematic model, the Ackermann steering mechanism, right? So we have seen alpha, means we have seen D, beta, R. Okay, we have seen the L1, L2, overall length L. Okay. See, we are going to consider the kinematic bicycle model of a steering system. We are considering only one wheel. It's one wheel. In the previous cases, what we consider as a complete, right? Front and rear, and we have seen everything. So here we are going to analyze in a different way, where we are going to consider the vehicle slip angle. Okay. And we are going to consider the orientation angle or the yaw or the heading. It's called as psi. So when considering this bicycle model, we are going to consider that the two front wheel are combined into one. Whereas in the previous case, what happens? Two different wheel we are considered, but here in this bicycle, what we are going to consider only one wheel. Combined two wheels combined to a one wheel. Two at the front is combined to one in the front and the one in the rear. And this bicycle model can be reasonable for low vehicle speed, having less than 5 meters per second. And here we are also going to consider the slip angle at the wheel is neglected. Okay. Let us go with the one considering the application. So we have del F and del R is an input. Del F is nothing but the slip angle at the front and the slip angle at the rear. And you see this is a different parameters, beta, R. Okay, you know this is XY, center of gravity. CG I'm going to write as XC, XY that's the coordinate, X coordinate and Y coordinate. And I'm going to solve this equation, means with the help of the governing equations. So we have seen a lot of governing equation previous, right? Now, similarly, we are going to have the governing equation for this as well, where we are going to consider triangle OAC and OBC. Okay. So here also we are going to have different parameters, where we are going to have two equations, one coming from this OAC and another coming from OBC, assuming that this is the front wheel, front inner wheel, and this is front outer wheel. So again, we are going to have two governing equation, which is 11 to L1 and L2 to that of turning radius R, and then the beta and also del R. Okay, all these are the things which we need to consider when we are when you are going for a design. So what happens when you are adding 1 and 2, you will get this equation, which is nothing but the turning radius R, which is based on the wheel base, to that of the angle beta, LF, which means uh, instantaneous angle at the front and instantaneous angle at the rear. Okay. So when you're solving all this, you're going to, why this equation is important? 1, 3, 4. Why we need to have this? But this is required to update the vehicle trajectory, because the vehicle have to move in the expected direction, right? Whatever the direction that is required. So that's why we need to have this equation while we are going for a design. Okay. So we are multiplying this equation with L2 and equation number 2 with L1. So we are going to have the final governing equation. So the equation number 1 OAC, for not considering OAC, because we are considering one, only in the bicycle model we are considering one, right? OAC. So here one equation number 3 and equation number 4 can be used to update the vehicle trajectory. Now there is important parameters called wheel alignment. We are going to see some important parameters, caster, camber. We are going to see those things now. Why we need to have the wheel alignment? See, this is the critical set of design and maintenance parameters, and these parameters have to be maintained in the specific design range to ensure the good vehicle performance and maximizing the tire life. And we need to inspect it during the cornering, straight line performance, during the tire wear, etc. And there are some signs of the poor wheel alignment. When the vehicle is pulling to one side, that is also because of the poor wheel alignment. And when you have uneven tire tread wear, that is also a sign of poor wheel alignment. When you have the steering wheel which is away, when it is off-centered when driving straight, that is also a sign for a poor wheel alignment. And if you have the steering wheel vibrations, all these are a sign of a poor wheel alignment. Okay, we need to have a proper wheel alignment. First, you have different parameters: caster, camber. Um, uh, you also have the toe into all these the wheel element parameters. First, let us see the camber. Camber is nothing but it is the angle made by the wheel and the tire uh, with a vertical direction when viewed from the front of the vehicle. See, I'm going to view the vehicle from the front. When I'm going to view the vehicle, okay, from the front, you see it is the vertical axis. This is the center wheel plane. Okay, the angle made by the wheel the tire with a vertical axis when viewed from the front of the vehicle. Okay, And you have two type of camber. One is positive camber and one is negative camber. So in the case of positive camber, what happens? If the top of the wheel leans away from the vehicle body, it is leaning away from the vehicle body, right? When the top of the wheel is leaning away from the vehicle body, it is called positive camber. What is negative camber? You see here the red is coming towards the vehicle body, which means the top of the wheel leans towards the vehicle body, then it is called negative camber. Okay, now you see here a small negative angle is camber is typically been introduced such a way that the car body, when during cornering, what happens? The vehicle moves left like this or right like this. What happens when the vehicle is going to turn left? The vehicle, the vehicle force, rolling will going to happen in this opposite direction like this. So when the car body rolls in this way during cornering, the tire becomes almost upright with roll, resulting in the best possible contact area of the tire and to that of road interface. So you need to have the negative camber for a better grip during cornering. Okay, for that purpose, you need to have this. And you also have the term called caster. Uh, let us, before going for this, let us see the important aspect here. If camber is out of adjustment, it will cause wear on one side of the tire we tread. And if the camber is different from side to side, it would also lead to the pulling. And you have other parameters, which is the caster. Caster is nothing but the angle made by the steering axis with its vertical direction when viewed from the side of the vehicle. Okay, you have two type of caster. One is positive caster and one is negative caster. Where positive caster is nothing but you see the steering axis, which is counting the lower joint, ball joint, and the upper ball joint. And this steering axis, when it is leans towards the rear of the vehicle, it is the front wheel, right? Front wheel, and we have the rear vehicle. When this steering axis is leaning towards the rear of the vehicle, then that is called positive caster. When it leans towards the front of the vehicle, it is called the negative caster. Okay. What happens is a positive caster will result in a trail that it also creates a self-aligning torque. Okay, you have the line, assuming that this is the longitudinal axis. Okay, and you also have a self-aligning torque or a moment, uh, which will cater to the improvement of the stability performance, means the steering effort. Okay, normally you need to have a high center. So you need to have a high caster, which will improve the straight line performance, and also it will have better stability due to higher self-aligning torque. But it leads to higher steering effort, lower maneuverability, and if caster is different from side to side, it may also result in pulling. Okay, so that's why this self-aligning torque movement is very much important to take care of uh, the better maneuverability, better steering effort, and to move away from the pulling. Okay. So these are all the. You have one more term, the wheel alignment, uh, caster, camber, and the toe. Let us see that toe in the next class. I I did not include it here, so let us see that in the next class. So as a complete session, what we have seen today is with respect to the steering system. Just let us have a quick recap. So we have seen the automotive steering system functions. What is this foot wheel steering? And we have seen the Ackermann steering system, and we have seen what is the governing parameters and we have seen the relationship between W and then the wheelbase, wheel track, and also the instantaneous inner wheel steering angle and then the outer wheel steering angle. And we have seen what is the relationship between the turning radius, considering the offset arm length D and then the beta with respect to the del O and then del I. We have seen different type of steering system, manual and also power assisted steering system. What are the pros and cons we have seen? We have seen the different components of the steering system. We have seen what is steering ratio. We have seen the manual assisted steering system in which the Pitman arm type steering system. Second thing is that the worm and successor steering box, worm and roller steering box, telescopic ball steering box, track and pinion steering system. C factor, we have seen what is that C factor. Power steering system, we have seen different types of power steering system, hydraulic power, electro-hydraulic power steering system, electric power steering system. And we have seen hydraulic power steering system and how the movement is going to happen when the steering is moving towards left and when the steering is moving towards right. And we have seen the disadvantages also because energy loss is going to happen in the case of hydraulic, and it will not work when the engine is stalled. So to overcome that, we are going with the power assisted steering, and we also have seen that hydraulic power steering. And we have seen the bicycle model governing equation, which is correlating the different parameters, beta, length, track length, and also we also compare this with WL or beta instantaneous angle. And we have seen different type of wheel alignment parameters like caster, camber. Toe is we will see in next class. Okay. Um, Wheel alignment. What are the different parameters involved for a wheel alignment? What is the significance of the wheel alignment? What are all the poor signs of the wheel alignment? And camber is nothing but when viewed from the top of the when viewed from the front of the vehicle, the angle made by the wheel, the tire with the vertical direction is nothing but the camber. And positive camber is the one which is leaning away from the vehicle body, and when it lean towards the vehicle body, it is called negative camber. Negative camber is good for a better grip during cornering. And we also seen the caster, where it is the angle made by the steering axis with the vertical direction when viewed from the side of the vehicle. And the steering axis leans towards the rear of the vehicle, and this negative camber is the one where the steering axis leans towards the front of the vehicle. We have seen what is that self alignment torque. Okay, thanks, and we will